one of the other companies that's helping to contribute to this security improvement is an Edinburgh-based company called Septillion. And we've got Chad Butz from Septillion, who's going to be joining us now. Hello, Chad.
Hey,
Hi, Trevor. Hi, Michael.
Yeah,
how are you doing?
Nice to see you. Okay, so maybe you Michael, you might want to lead on this, but maybe you can bring us up to date with what Septillion's doing with their markers for trying to protect against counterfeit.
Yeah, let me just kick off the context here, because we were talking earlier about the secure supply chain, and you literally have a trusted entity putting something in a box, and you have another entity in a trusted environment opening the box. But in between, you've got the white van man who, paid minimum wage, could be approached. And it's not just, I'm not picking on a guy who drives a white van. There are so many different responsibilities throughout the supply chain. How can you be absolutely sure of the content? And so traditional barcodes and labels, what man can create, man can duplicate. And so you can never really be sure. So Septillion have got a really innovative new technology which completely eliminates this whole threat. So Chad, I hand it over to you.
Thanks, Michael. First of all, thanks for having us. I just heard Michael talk about what role blockchain plays in the security in the chain of events. And one of the founding principles of the business was a view that so much effort has gone into the digital systems that sit behind supply chains. And I also think I heard Radu talk about cybersecurity. So there's been so much effort put into the systems end of it, but the weakest link still remained that connection between the digital system, the technology system, and ultimately the physical item. And one of the reasons for that weak link was many of the tools that are used to perform that physical connection with the box or with the product is a tool that actually wasn't truly meant for authentication. It was often, perhaps whether it's a barcode or a QR code, these tools were meant for either serving the purpose of serialization, or in the case of something like an RFID tag, serving the purpose of track and trace. So they do a decent job at the job they were intended to do, but what they don't do a decent job of is the job of authentication. So what we aim to do is create that physical link. And as Michael said, with something that was innovative in that it's duplicable as a label, but it can be deployed in virtually any environment where there's a package or a label involved in moving a product, or even some cases going directly onto a product itself. And that then completes the completely secure link from the physical product to the digital system. I can tell you a little bit more about how the technology itself works, if that helps.
Yeah, that is interesting. I mean, because when I first spoke to your collaborator about this technology at Septillion, you were talking about putting unique markers potentially into components at the time and materials. You were using banknotes as an example. So what are you saying now? Are you saying that you're going to create a unique padlock of some sort, or thing that can be attached to the packaging that can't allow that packaging to be opened without it setting off some sort of warning or alarm, within the blockchain link?
Not quite the latter point about setting off a warning, but the base technology has actually been around for a long time. So what we use are security fibers embedded into a paper, a polymer, or another type of substrate. So the base application was actually an analog application, and you've often seen security fibers used in passports or banknotes in the past. What we created was the ability to read that and scan that with a camera-enabled mobile device through an app. It's a machine vision technology that applies an AI reading to that fiber distribution, which is inherently random, or as statisticians call it, true random. The AI algorithm reads it at both in distribution sense, but also a depth sense. So that makes it truly non-duplicable. You cannot reprint that. You cannot take a picture of it and recopy it. And just in terms of the added encryption that then happens in the algorithm itself, you also can't reverse engineer it back from a digital system to a physical product in any way. So the most straightforward application, because we're actually using a physical technology that started in paper, is to put it on a label, is to put it into packaging itself, which is possible. So anywhere that you can put a fiber into a pulp in the production process is definitely a viable use. Polymers such as banknotes, and we are investigating other substances. So what we can absolutely do is authenticate that as a product has moved from point A to point B to point C, possibly through that white van man that Michael mentioned, that at no point was the package, the label, or indeed the product swapped, because the label itself often will act as a tamper-proof piece of evidence that there's been no physical tampering with the item either. But it's fundamentally an authentication product.
Yeah, the receiving operation is very, very interesting, because you get a package. It's like getting something, you know, from Amazon or whatever. You know, you just want to make sure that it's fine. And you look at the packaging first of all. You know, has somebody cut a hole in the bottom of the box, taken the stuff out and tried to patch it up again? Well, that's going to be fairly easy to tell that something's gone wrong, so that you're not going to use that. But then what about the box that comes in and it's had the seal cut? Again, you can see that. We can have tamper evident seals. That's absolutely fine. But what about the case where somebody comes along and recreates the packaging so that it looks absolutely fine, and a new label's been put on, a new seal, there's no cut or anything? So then the fiber code comes into its own, because when you read it, if they've been able to even try to simulate it, which is extremely difficult, it's not going to pass. There's nothing they can do to copy that label. It just cannot happen. And of course, if there's no fiber code embedded, they don't see anything at all anyway. So this is a real...
Yeah, it's definitely one scenario. Another scenario which does happen is a case where there has been a theft or some type of diversion of the packaging itself as a pre-serialized piece of packaging, because that is also a known weak link. A fiber code generates its own code, and it doesn't generate it. It doesn't have meaning in a security sense until it's enrolled on site, whereas often serialized identifiers are produced at print. So as Michael said, if that is simply duplicated and it's a barcode and it's the same code, to the reader it would be the same. Ours only has meaning once it's enrolled in the field.
So Chad, to make this work effectively, I mean, really, it has to be embedded into some kind of standard with the association here, so that the OEMs are going to specify that you have to supply your components to me, Mr. Chinese component manufacturer, to IPC standard XYZ, and then he then has to enroll, as you say, and take part in this program to put this security authentication onto the product after as soon as before it leaves this factory.
Yeah, we've developed the technology alongside the work and the contribution with 1782A, but to be sure, there are still questions and challenges about the real world implementation, because different settings, different manufacturers, different packaging standards, they will be different in different environments. But that's where we see scalability, not just in the sort of system sense, but by the fact that the base production technology of putting security fibers into paper or polymer has been around for a long time. It works on high-speed lines. It works at scale. It works as a low-cost item. So the ability to go to your suppliers and say, we'd like to adopt this label or this type of packaging shouldn't be a great leap in terms of implementation of this solution.
It opens up interesting questions, this, because typically manufacturers go through a lot of the big box, what we call the big box component shifters, the DigiKeys, the Arrows, the Avnets of this world, because they kind of put the onus of checking the veracity of these components, the integrity of them, should I say, onto the big box companies. So people tend to try and avoid the grey market wherever possible. But if there's a system where you can absolutely guarantee these devices are correct, is there going to be any need to go and through the big box guys and pay the premium that they're demanding in the future? You know, does it not just open up the whole market?
Let me just answer that
go ahead,
from the
Mike.
standard perspective, because that was one of the key things that we wanted to achieve. That if you assign the responsibility so that you know the origin of any issue, so that using the fiber code, you know that the transition from one responsibility to another is perfectly understood and there's no way that it could have been tampered with. That means that we can effectively drive out the risk of counterfeit material in the supply chain, because the guys get away with it right now because you cannot track it back. You can use traceability within assembly to go to the incoming package, but if you're dependent on a barcode, you can't go to court with that because somebody could have duplicated it. With fiber code, you can, because you've effectively got a signature from the producer and you've got this evidence of no tampering. And so you can then say, look, I know exactly the responsibility for this tampering. And therefore, the guys who are doing it say, well, okay, game over. You know, it's just too much of a risk now. I really face some serious jail time because I know I'm going to get found out.
Well said.
It's really interesting, but I mean, of course, with increased traceability becomes increased accountability. You know, so if some component is found to be defective and have to cause a major accident, then you can literally trace it back to its point of origin. So there could be real side effects with all of this, but it's really interesting.
And you know, the final key to that is adoption. You know, it's something that can be readily adopted at scale in a world that demands, you know, quick implementation times, quick turnaround, supplier changes, you know, cost pressures. And that's one of the factors as well, is if you get secure authentication adopted at scale in the field, it just makes every aspect of a traceability system much more effective.
Yeah, fascinating. Well, Chad, I want to thank you for coming in today. It's really interesting stuff, and we look forward to hearing more from you. When do you think this standard is going to be ready, and when do you think we're going to be implementing some of these technologies?
It's just been published actually within the last month or so. So it's available in the IPC bookshop, IPC 1782A. We are currently looking for opportunities to do proof of concept. That is to physically use the fiber code together with a blockchain implementation and prove that it works. And it works not with a huge cost, but because it's standards driven and because we're using very effective scalable technologies like fiber code, that we can do it now. We don't need to be waiting for anything else to happen. No. It really is out there and ready to use.
Right. I hate to. Shouldn't you have done that before you created the standard? Shouldn't you have done the proof of concept first and showed that it worked before you built a standard around it?
Within IPC, it's a consensus of many different people. So, you know, we put all of these ideas together and we come up with, in this case, an idealistic idea, because you have to realize that the supply chain is a global entity. And, you know, we are facing a lot of different conditions. But the people who've been contributing mainly to this standard include Septillion, for example. And so it's by understanding how this whole process works, the holistic journey of the product, that we can start to put these things together. But when you start to do a proof of concept, you're involving the people like the distributors and the component makers. And it is a bit of a challenge to get them to buy into this, because there are small projects and proprietary technologies that aim to solve the problem. They're very expensive and they're very intensive to use. Our value from the standards perspective is that any technology can be used, and we'd like to show the proof of concept using this specific technology because it's available now, it works, and, you know, it shows the value of the standards adoption.
Right. Well, it's certainly there's a huge demand for it in the industry. So I hope to see it being tested and implemented very shortly. But Jad, right now, thank you very much for joining us today.
Thank you, Trevor. Much appreciated. Thanks,
Yeah,
Michael.
thanks a lot.